Welcome to Geometry. This is beginning chapter 1, which is the basics of geometry. Today we're starting with section 1.1, which is talking about patterns and inductive reasoning. But just to give you guys a heads up, this chapter 1 seems to really have not much rhyme or reason. Wouldn't you agree with me, Mrs. Palermo?
Yeah, it's just a hodgepodge of stuff. It has a lot of introductory terms, concepts that we're going to be using throughout this course that you're going to be seeing a lot. Even when we get to the end of the year in May.
Yeah, definitely a lot of stuff that we're going to keep seeing, but it doesn't necessarily fit together super smoothly throughout this chapter. So, guys, just be prepared because you're going to say, wait a minute, this doesn't have to do anything with what we did yesterday.
Yeah, it doesn't build, but it's a lot of stuff that you're going to see. And so keep that in mind because of the fact that we're going to be focusing on these concepts as we progress.
All right, so we're starting off with the 3 stages of reasoning in geometry, and we're going to be focusing on inductive reasoning.
Inductive reasoning has 3 stages, of course, like Mrs. Hochgraby said. We have the first stage is look for a pattern, and patterns you guys have dealt with before, so this is not a new concept, nothing to be scared of, but think about when you have looked for a pattern, you have to look at several examples first. Sometimes you have to draw a picture or look at a table kind of to see what's really happening in the example.
Absolutely. And the next stage is to make a conjecture. And a conjecture, that's a new vocabulary word. It's an unproven statement that is based on observations. And yeah, unproven is the key word here. We don't know for sure that this is true. A lot of you in science have talked about the scientific method and making a hypothesis. Similar idea in the fact that we don't know for sure that this is true in every case, but we're noticing through these observations, through these patterns that we're finding, that something seems to be happening every single time. So that would be making a conjecture. Notice it's based on observations, though. Hypothesis, you're just guessing in science. Where here we've got some observations and some data already collected, and now we're making our unproven statement.
And to stress off of that, the conjecture, because it's unproven, it could be true or false. And so the third step is to verify that conjecture. So you have to test it, kind of to see if it works for all cases. It may work for maybe one case or a few cases, but if it doesn't work for all cases, then that conjecture is actually a false conjecture.
All right. So to recap our 3 stages, we said we want to first look for a pattern, we want to make a conjecture, and we want to verify our conjecture. Now, we talked about how not all conjectures are true. If you find out that there is an example that shows a conjecture to be false, that's what we call a counterexample. So a lot of times when we're looking at conjectures, we may be determining, well, is it a true conjecture or is it a false conjecture? And to prove something to be false, we're going to just need to show one counterexample. To prove a conjecture true, you would need to prove that it was true for every single case, which in math, when you start thinking about numbers, that there could be an infinite number of cases.
Yeah, it's definitely more work, more of a process to prove something true. Counterexample, like Mrs. Hochgraby said, you only need one counterexample. And if you come up with one and you can only think of one, that conjecture is still false.